This is the first video of a four-part series on the different types of problems you can come across that involve intervals when using kinematic equations. So the first type is when you have two different velocities. Here we have a car moving with a constant velocity of 50 meters per second forward and does that for 6 seconds. In our second interval, we're going to have the car moving at a constant velocity once again, but it's moving for 243 meters, and you notice the constant velocities are different. The first interval we're moving at 50 meters per second, and the second interval we're moving at 65 meters per second. So the way I like to start this is trying to break down my intervals. So I'm going to start off by making my reference frame. So I've got backward and forward, and I'm starting at some position A, and I'm moving my way to this position B, where I magically and instantly change my velocity to 65 meters per second to this location C. And other things I like to include in my diagram is here is my velocity at A. So I'm moving at 50 meters per second. So this is my velocity vector. And my acceleration during this interval is 0. And at B, I'm still moving at this. Actually, no, what? I'm not moving at the same acceleration. This is where it's kind of a little interesting in this problem. What I'm going to do here is at B is where I kind of switch, right? So for this one, I'm going to show that I'm moving at this velocity here. And obviously at the end, I'm moving at this same velocity. So I'm moving at this velocity B for my second interval. Now, usually this way of doing it works well because we usually have a proper transition. This first interval will be moving at some velocity, and then maybe the second interval we're accelerating, or in the first interval we're accelerating to this other velocity. So it'll look a little more clean, but we'll just do this. In both situations, we're not accelerating. Let's write our given and use the same variables we used in our example here. So we've got VA is 50 meters per second forward, and that happens, call this time from A to B. That is our 6 seconds, and then we also are going to include our second velocity here is 65 meters per second, and that's forward as well. And my time from B to C, we don't know, but we do know the 243 meters as our distance we traveled. Okay, so to get started here, we're trying to figure out what the average velocity is. To start, let's just think about what is average velocity. So average velocity is the displacement we traveled. So this would be our displacement from A to C, and over our time, the time of this trip. So we're going to need to know what this total displacement from A to C is, and then we're going to need to know what our time is to get there. So we're going to break this down into these two intervals here. So this first interval, what we need to figure out is how far did we travel, right? We have the velocity, and we have the velocity, and we have the time. Let's figure out what displacement is. This is a constant velocity, so we're going to use the constant velocity equation, right? So we're going to use like we'll call this just our average velocity is VA in this case. And that's going to be our velocity for this full interval. And then we've got our displacement from A to B. That's what we're trying to find. And we have our time. So I'm just going to rearrange this equation for displacement before putting in my variables. You could have wrote it like this from the start. And we get, by substituting our values, we've got our 50 meters per second. And I'm saying that forward is positive and backward is negative. So I don't need to write the forward in here. My positive does that for me. Just saves having to write forward in here for this vector. And then my time is 6 seconds. So we got 50 times 6, which is 300. And this is, you can see here, we cancel out those units there for seconds, and we get meters. I do like to, though, when I get my final answer, I like to write it properly as a vector. And so that's going to be 300 meters forward. Okay, so that's our interval 1. Let me just label that. This is interval 1. Okay, so we'll call this 1 here, and this 1 2. So let me just move this equation here out of the way. So that's what we'll do. We'll do our second equation, our second interval, I mean. So for interval 2, I'm going to now look at my velocity, my second velocity here, and it's also a constant velocity, so I'm going to be using now this equation for the second interval. So what am I given here for the second interval? We know the velocity and we know the displacement. So I'm looking for time here. So this will be my displacement from B to C, which doesn't say in the question it's forward, but we need to assume so. Oops, sorry, this should say VB. And let's solve for our unknown for this interval. So we have 243 meters. That's forward, so it's positive. And then our velocity is also positive, and it's, I believe it was 65. We've got 65 meters per second forward. All right, putting that together, we're going to get our time. Right, these meters are going to cancel out, and the second will go to the numerator, and we get 243 divided by 65 is 3.7. So there's our time we traveled in that second interval. So why did I do this? Well, we're trying to figure out what our displacement is to go from A to B to C, right? We want to know that displacement, and we also want to figure out what the time it was to go from A to C. What was that time? So we now have everything. We now know, we can now figure out what our displacement, I should have a little hat on that. What is our displacement from A to C? Well, that's just the displacement of our first interval from A to B. And then we need to add our displacement in our second interval, so B to C. And when we add those together, we will get that displacement from our start to end. So we calculated our first answer here is 300 meters forward, and our second interval was given to us, right? It was given us the question as 243. So adding that together, we get 543. So that is our displacement. We've got that so far. That's good. Now we need to use our time. So our time to go from start to the end point is going to be the sum of our times from A to B plus our time from B to C. Now you may find like doing all these letters is tedious, but it really works well to keep things organized and making sure that you don't make any careless mistakes, and also making the reader understand what you're talking about. So we got 6 seconds for that first interval that was provided in the question. That was the time that was given at 6 seconds, and then we calculated our second interval. We did that for 3.7 seconds. So that gives us a time of our total journey here is 9.7 seconds. All right, and then let's just put it all together. So I'm actually going to take this formula that I moved to the side here, and I'm going to move it to the bottom. Let's take this down here and put this all together to get our final answer. So let's put in our displacement is 543 meters, and we'll put in our time, 9.7 seconds. And we get 55.98 meters per second. And let's write this as a vector again, forward. And this is my average velocity for this trip. Now, it's not two correct significant digits, but the process is what we're concerned with right now. And we'll just write this out. We'll box this answer. I like to just clearly state the final solution. Let's write this. And you can write a little conclusion. The average velocity of the car for the trip is 5.98 meters per second forward. All right, so that's kind of our most basic interval problem. Let's move on and take a look at some other ones. And these other ones are, just so you're aware, we've got our reaction time problems. We got other ones where we're just maybe accelerating in one interval and moving at a constant velocity in the other. And we also got some chase problems, like when we have two people, like we're doing a race, trying to figure out who will win, or how long it takes to kind of catch them and where they'll be located, all that kind of stuff. So let's get on it.